Using standard deviation, we can form something called a z-score to help us compare values from different data sets or different distributions. So we'll measure the relative position of a single value by the z-score. And the z-score is just the number of standard deviations that a value is from the mean. So it's in relation to the mean. This is the formula for z-score. So it's the value, data value, minus the mean, that's Greek letter m, and then divide by the standard deviation. And these are population values. Now, if you have sample data, you can find a z-score by taking, again, the value minus the mean, divide by the standard deviation, s. So let's look at an example. So Karen and Maya each had a bone density test. Karen's total hip bone density was 0.742 and Maya's was 0.684. Who had the higher bone density relative to their age group? So relative there, that keyword is telling you want to use z-scores so you can look at each person relative to their age group. So for individuals age 60, female individuals age 60, here are the mean and standard deviation for bone density at the hip. And for age 70, here are the corresponding mean and standard deviation. So we want to figure two z-scores. So these will be respective. Okay, should have mentioned here. Okay, so let's say that Karen is age 60, and let's say that Maya is age 70 for this example. So Karen's z-score is going to be the value minus the mean over the standard deviation. So x minus mu over sigma. So her bone density value was 0.742. The mean for her age group was 784. And then the standard deviation for women her age, 0.461. And to two decimal places, this turns out to be negative 0.09. And you almost always round z-scores to two decimal places. For Maya, we're going to do the same calculation. So the value minus the mean. So her value is 0.684. Minus the mean for her age group, 0.708. And then divide by the standard deviation for her age group, 0.375. To two decimal places, that is negative 0.06. So if you have a z-score of 0, you're at the mean. So both of these are below the mean. So notice here that z less than 0 is below the mean. And z greater than 0 is above the mean. So both of these are less than the mean for their age group, but we want to know which one is further less. Well, Karen's z-score is less than Maya's z-score. So we see that negative 0.09 here is less than negative 0.06. It's more negative. So that means we're saying who has the higher bone density. So the negative 0.06 is higher, the negative 0.09 is smaller. This is Maya's bone density. So Maya has higher bone mass density for her age. And if you ever have a bone mass density test done, they will give you a z-score for your bone mass density. They'll also give you a t-score. The t-score compares to a healthy 30-year-old. So your t-score is almost always negative because your bone density is less than a healthy 30-year-old. But this is in relation to people that are the same age as you. the z-score is comparing to your age group. So that's pretty cool. We can compare with different distributions using z-scores. Now, to kind of get a picture of what this is telling us, we've got a mound-shaped distribution. So the bone mass density scores will be a mound-shaped distribution like this. The mean will be in the middle. So that is mu, and that corresponds to a z-score of 0. So x value and z value. And then we'll have, this is for age 60, we've got one distribution. But then if you convert to z-scores, it lets you compare different distributions. So we actually will just have one distribution that we can put both z-scores on. So Maya's z-score, negative 0.06, would be about right here. And then the negative 0.09, that's going to be to the left. So, and this is negative direction and positive direction. So this one is the negative 0.06. And this one is the negative 0.09. So they're both below the mean, but this is 6/100ths of a standard deviation below the mean. This is 9/100ths of a standard deviation below the mean. So for example, a z-score of -1 means that your data value is 1 standard deviation below the mean. And if you had a z-score of 2, that implies that your data value is 2 standard deviations above the mean. Remember, positive above, negative below.